for the first part of this unit, we're going to be talking about things called valence orbitals, and I do want you guys to copy this down. Valence orbitals just basically means the outside shell of an atom. So we've talked about this before, but we talked about how an atom has a nucleus in the center, and the electrons fly around it, and they fly around in these regions that we call shells. The one on the outside, this is called the valence shell, okay? Just make a note somewhere that valence means outermost. Okay, so if an element has 2 shells, the second shell is the valence shell. If it has 3 shells, the third shell is the valence shell. If it has 6, it's the 6th, so on and so forth. Okay, pretty simple. All right, another term that we need to know are something called valence electrons. And valence electrons, you guys don't even need to write that term down. It just means an electron that's inside of the valence shell. Okay, so there are electrons in these shells. If there's an electron in the outside shell, we just call that a valence electron. Okay, so valence just means outermost. So if you have a valence electron, it's an electron in the outside shell. Okay. Any questions on that concept? Just kind of vocabulary, but. All right, so we haven't talked about, or you guys haven't seen electrons and shells in a long time. I think it was first semester, so we're going to go through how to find it. So I want you guys to take a look at your periodic tables, and I'm going to talk about how to figure out how many shells an element has and how many electrons it has. Okay, so it's very simple. So we're going to first talk about shells. Okay, the number of shells that an element has, it's just basically what row it is in. Okay, so somewhere on your notes, you guys can write that down. Depending on what row on the periodic table, rows go side to side, that is how many shells an element has. Okay, so if you have your periodic table, it's pretty easy to figure out how many shells an element has. So let's just do a quick verbal pop quiz. If I look at magnesium, how many shells does magnesium have? 3, yeah, it's on the 3rd shell. If we're looking at radium down here, how many does it have? 7, yeah, it's the 7th row. Pretty easy, right? Just what row it is in. All right, so next thing we're going to talk about is how many electrons an atom has, and this one's pretty simple. It's the same as the proton. It's the number on top of the box. Okay, so we're going to write down, it's going to be the atomic number. Okay, so if we look at magnesium again, it has a 12 on the top, so it has 12 electrons. Radium has 88 on top, so it has 88 electrons. Super simple. All right, so far so good? Okay, this actually should be a review. If you guys remember, we talked about this a while ago. We're just kind of reviewing it. All right, so we also talked about this before, but you can draw an atom using the periodic table. So we're going to briefly review how to draw something called shell models. Okay, so shell models. Okay, and shell models are a way of drawing atoms where we draw their shells and their electrons. Okay, so I'm going to go over how to do it. We're going to do a few examples, and then I'll have you guys try some on your own. Okay, so let's start with let's start easy. Let's start with helium right here. Okay, so we're going to be drawing helium. Now helium, if you guys notice, is in the 1st row. So how many shells does it have? 1. So to draw helium, what we're going to do is we're going to write the symbol. We're going to write He, and then we're going to draw 1 shell around it. And if we look at helium, how many electrons does it have? 2, yeah, number on top of the box is 2. So we're just going to put 2 electrons in that shell. And that's it. That's how you draw the shell model for helium. All right, so it's pretty simple if we just have 1 shell, but most of the elements have multiple shells. So we're going to talk about how to draw elements with multiple shells. So let's look at oxygen right here. So for oxygen, how many shells does oxygen have? 2. Yeah, it's in the 2nd row. So we're going to write the symbol O, and then we're going to draw 2 shells. All right, let's look at the electrons. Oxygen's number 8, so it's going to have 8 electrons. So I'm just going to jot this down here. It's going to have 8 total electrons. Now the trick is to figure out which shells the electrons go into. So we always start from the inside out. So if you look at the first shell, remember how we talked about the row numbers, right? The rows tell you about the shells. Well, if you look at the first row, there are 2 boxes, right? 1, 2. That means we put 2 electrons in that first shell. And then to get a total of 8, we just put the remaining 6 in the second shell. Okay, and there you go. That's how you would draw oxygen. Okay, so if you have multiple shells, just start with the inside one first. Just count how many boxes there are in that inside shell. Fill that one in, and then you just move out from there. Okay. All right, let's have you guys try one on your own. I want you guys to try drawing Na. Draw the shell model for sodium. I'll give you guys about 2 minutes to do that. See if you can do it with the person next to you, and then after that, we'll go over it and move on to the next topic. Right? If you look at Na, it's on the third row, so it's going to have 3 shells. And how many total electrons will Na have? Yeah, 11, number on top of the box. So that means we need to draw 11 electrons total in these shells. So let's start with the inside row and move out. If you look at the first row, you see how there's 2 boxes, right? So we're going to draw 2 electrons in the first shell. Okay. So first row has 2 boxes, so it's going to have 2 electrons. Okay, second row has 1, 2, 3, 4, 5, 6, 7, 8. So we're going to draw 8 in the second shell. And then if you look at Na, there's only 1 in that third shell, so we put a 1 right there. And if you want to count them up, you can, but you should have a total of 11. Okay? And that's it. That's how you draw shell models. I'm not going to give you anything like far down here. I probably won't give you anything past the third row because it just takes a lot of time, and you kind of get the general idea. Okay. Alrighty. Any questions? Easy peasy. Okay. Let's add one more thing onto it, and then we will be all done. So we talked about this before as well, but we talked about how elements, they don't stay normal. They like to gain and lose electrons. So let's write down the terms for that real quick. So when an element gains electrons, okay, so when it gains electrons, the element becomes negative. Okay, and we call that an anion. Okay, so if an electron or an element gains electrons, it becomes negative, and we call that an anion. Okay, but if they lose an electron, it becomes positive. Okay, and we call that a cation. Okay, so what we're going to do now is we're going to learn how to draw the shell models for these cations and anions when they gain and lose electrons. And honestly, it's pretty easy. You just need to figure out, you just need to erase or draw more electrons. Okay, so let's start with an example. We're going to do O2 minus. Okay, this is our first ion. And if you take a look right here, it's oxygen, right? But it has a 2 minus. What the 2 minus tells you is that it's going to gain 2 electrons. If it was 2 plus, that means it lost 2 electrons. But since it's 2 minus, right, that means it gained 2 electrons. Okay, and drawing the shell model for this is very simple. What you do is you do everything the same way first, and then you just need to add or take away electrons. So if you look at oxygen, we already drew this, so I'll kind of draw it for you. We talked about how it has 2 shells, and normally oxygen has 8 electrons, right? So we would draw 2 in the first shell and 6 in the second shell. Everybody good with that so far? Okay. But it's not just regular O, it's O2 minus, so we have to write the 2 minus in the middle. And since 2 minus means that it gained electrons, we just need to add 2 more electrons in the outside shell. And that's pretty much the only difference. Okay? So regular O will have 2 electrons in the first shell, 6 in the second shell, but O2 minus is going to have 2 electrons in the first shell, but 8 electrons in the second shell. Okay, so it's literally just oxygen, but we just added 2 electrons to the outside shell. That's it. All right, any questions on that? Think you could try one on your own? Okay, so I want you guys to try, let's do N3 minus. I want you guys to draw the shell model for N3 minus. Give you guys about 2 minutes to do that, and then we'll do one last example problem, and then I'll get you guys started on your assignment. All right, so for N3 plus, we have, or sorry, N3 minus, since it's 3 minus, that means we gain 3 electrons. Okay, so what we're going to do is we're going to draw a regular N and just add 3 electrons on top of it. So we're going to write N. How many shells does N have? 2, yeah, second row, so it has 2 shells. And regular N has 7 electrons, right? So we're going to put 2 in the first row, so 1, 2. And if you notice, the first shell always has 2, so you can just kind of remember that to make it easy. And then we got to get 7, so we're going to draw 3, 4, 5, 6, and 7. Okay? But since it's N3 minus, we add 3 electrons, so we just add 1, 2, 3 for a total of 10. That's it. So N3 minus is going to have 2 shells. It's going to have 10 total electrons. Okay, that's pretty much it. Any questions? Easy peasy? Okay. All right, so let's do our last example, and then we'll be all done. So if you notice, the 2 examples that we did were negative ions, right? They were anions. It's a little bit different when we have a cation, though. So I'm going to show you guys how to draw a cation. We're going to draw B3 plus. Okay, B3 plus. All right, but before we do that, I want you guys to take a minute, see if you can draw regular B. Draw the shell model for regular boron first. All right, so hopefully regular B was pretty easy. Second row again, so it's going to have 2 shells. And the number on top of the box is 5, so we're going to have 2 electrons in the first shell, and then 3 in the second shell. Okay, everybody good? Okay, so I'm going to write down some of its, I guess, stats underneath it. But it's going to have 2 shells, and it's going to have 5 electrons. Okay? All right, but we're going to draw B3 plus now, and since it's 3 plus, that means that we lose 3 electrons. Okay, so what we're going to do is I'm going to show you guys what it's going to look like on B. But what we're going to do is we're going to take away this electron, and this electron. Okay, now if you notice, we got rid of all the electrons on the valence shell, right? And so that means that this second shell is now empty. And when we have an empty shell, that shell basically stops existing. So if we're going to draw B3 plus, the way it would look is it would just be 1 shell with 2 electrons, because that outer shell just disappears. So just so you guys can compare it, I'll have them next to each other. But regular B has 2 shells, and it's going to have 5 electrons. But B3 plus, you lose 3 electrons, which are the outside electrons. So B3 plus is actually only going to have 1 shell, 2 electrons. That's going to be the difference between the ions. So a little bit different when it's a positive ion because you lose electrons. Okay, so the last thing I want you guys to write is that when you have a cation, what that means is you're actually going to lose the outside shell. Okay, so that's kind of a note that'll help you guys as you do your problems. Okay, so for an anion, you keep the same number of shells, but for a cation, you're going to actually lose that valence shell. So if you ever see an ion that's positive, you're probably going to have 1 less shell than the normal element.